What are complex numbers? So as far as you're concerned, the number line looks like this. But if you're a caveman or woman, negative numbers don't actually make sense to you, because it's pointless saying, oh, there are -3 saber-toothed tigers over there. It's just meaningless saying -3 of an animal. Or it's pointless saying, oh, there are -4 mammoths over there. You see, negative numbers makes no sense to a caveman or woman. Well, you living in the modern world, negative numbers actually do make sense, because you could have a temperature gauge where 0 is ice, water freezes at 0 degrees. If you have 37 degrees Celsius, it's going to be really hot. You could have a -1 degree Celsius, -2 degrees Celsius, and so on. So here it's going to be very cold. This is going to be even colder, and so on. You could have a negative temperature. Or another example is this is you here, and this is me. If you owe me $4, then you, as far as you're concerned, you actually have -$4. So negative numbers actually make sense in our modern world, because negative numbers can be used to represent debt. It can be used to represent debt. So in the modern world, negative numbers make sense. Now, when you're 16 or 17, you will be introduced to what's called complex numbers. So as far as you're concerned, you only understand things that are living on this line here. When you're 16 or 17, you will be introduced to a new axis. This is called the imaginary axis. This is called the real axis. So you're like a caveman or woman. You only understand things that are living on this line. This imaginary axis makes no sense to you. So when a magician says to you, think of a number, well, you do have the right to say this. This is a number right here. This number here is 3 plus 2i. 3 plus 2i. This is also a number. This number here is 4 plus 3i. So this happens to be a complex number. So a complex number has two components. It has the real component, and then it has an imaginary component. So this here is also a number. This here is also a number. This number happens to be -3 plus 2i. This is your real component, and this is your imaginary component. This here is also a number, -4 minus 2i. This is a number, and this here is also a number. The real component is 3 plus 0i. There is no imaginary component. This here is a number, but we don't bother writing 0i. We would just write 3. So this number is 3. You see, this number here is a complex number. The real component is 0 plus the imaginary component will be 2i. But we don't bother writing 0. We're just going to write 2i. This here is a number here. This is actually a number. Right here is a number. This number here would be 0 plus 1i. This is your real component. This is your imaginary component. It's pointless writing 0, so we're just going to write 1i. But then it's pointless writing 1 here. We're just going to write I. You see, this is a number right here. The number there is just I. And this here is a number. It is negative 2i. This here is a number. So as far as you're concerned, things that are on this line make sense to you. Things on the real number line make sense to you. But when you're 16 or 17, you will be introduced to complex numbers. So you extend it. So this is your imaginary plane. This is your imaginary axis. This is your real axis. So the reason why we're doing this is because of this. Hang on. We would invent this thing called complex numbers. So for example, 3 plus 4i. We would invent this this new numbering system. Well, you can manipulate. We would manipulate complex numbers. So for example, you could add it to another complex number. Let's say 2 plus 7i. So you can add one complex number to another, or we could multiply them, or we could square a complex number, or we could cube a complex number, or we could square root a complex number, and so on. The point is that we invented a new numbering system where we can manipulate it in the imaginary world. We would do some sort of computation on this number, and then right at the end of it all, we would get an answer in the imaginary world. So, for example, let's say the answer is 10 plus 8i. Well, this 10 plus 8i is meaningless. It only exists in the imaginary world. But once we've got our answer, once we've done some sort of computation and got our final answer, this is our final answer, we can convert it back into the real world. So for example, this we would convert this number into the real world. So the number 10 would be meaningful in the real world. So it's the point is that we manipulate complex numbers. We would apply lots of computations onto this number, and then we would get to a final answer. So our final answer could be 10 plus 8i. Once we've got this answer, we would convert this answer into the real world, and it will have some sort of meaningful representation in the real world. That's why we invented complex numbers. Okay.